Okay, so I've just brought the coach back into the frame just very briefly. So I've taken out the internal compartments, but the circuit board will be sitting about here. I think what I want to do is to pop the switch just directly under here, because it'll be, there's a wee tank here and part of the brake here. It'll be fairly well hidden behind that. And then what we can do there is to feed the wires for them straight up through there, and then here the bogies here, we'll use this front bogie for the pickups, so we'll pop the wipers on one side or the other, and then we can feed the wires through the central hole here and up inside. So I think we'll work on that premise anyway. So I'll move on anyway now to getting the switch in and getting the wipers on the bogie, and as well, just to aid that, I'll pop this bogie off so that we're not constantly bringing this lovely carriage into the frame and potentially putting it at risk. So we'll get the bogie off and we'll start getting the switch into place. Okay, so the next step kind of depends on the type of switch you've got and also the particular coach you're doing as to where the location or the prime location is to stick it. Now, for the one that we're using here, this side here, in between this little box and this bit of brake assembly here, is where we want to pop it. This one as well has got bent legs, so I will just bring in my pliers here and just straighten those out. So the way that I like to do this anyway is just to basically line up where we want it, and then I use my permanent marker pen, which has gone walkies, but anyway, just a little permanent marker pen just to mark where each of the legs are, and then I get my pin vise and a little drill, and then I just drill 3 little holes so I can sit those legs in. And once I've sat those legs in, I'll apply a little bit of super glue to the underneath there, slide it in, and then that is the switch stuck in place. Then we can turn everything over and do the wiring from the inside. Okay, so that's the 3 dots marked in there, so I'm just going to take this pin vise and drill those holes through as I explained before. That's 1, and I'll just carry on and do the other 2. Okay, so that's the 3 holes drilled, and we'll just offer up the switch. Hopefully I've got my spacing correct. There we are, brilliant, yeah, just right. And if you get the spacing just right, then it's nice and snug, and that'll help to hold the switch nice and firm as well. Brilliant. And as we can see from the other side there, they'll just poke up, and what I normally do is just push it back a little bit, pop some super glue in to hold it in place, and then I sometimes pop a little bit of super glue just in through the hole, just a tiny little bit on this side as well. So I'll do the super gluing, and then we'll come on to the wiring next. Okay, so we'll start with the bogie itself. So we just need 1 of these pickups, and you get 12 gold-plated phosphor bronze wiper sets. So we only need 1. You can put more on if you want, just to get better pickup off the track. But I tend to find that as long as you're using one of these stay-alive capacitors and you keep this single one clean, then you don't really need more. But if you did want to put on more, you can certainly do that. Okay, so what else do we get in the pack? Well, we get the little pickups, and we also get the screws. You only need 1 screw per pickup. Sometimes you might want to put a wee dab of glue on as well, just to hold it in place, but the screw, which is self-tapping screw, should be able to do that on its own. Now what I normally do for this is I do a wee dry fit first, so I just squeeze it on between the wheels. It can be a little bit fiddly. Let's see. There we go. So it's in between the wheels there, and I line it up so that it's got good contact and not getting in the way. And then I get a little permanent marker, and I kind of mark in there exactly where I want to put the screw. And I then get a drill bit, which is normally about half the size of the screw, so or maybe a 1mm drill bit, and I drill through, and then we'll screw it in. So I'll go and mark it just now, and then I'll drill a hole, and then we'll come back and we can fit the wiper. Okay, so that's the wiper fitted in now. So we've used a single screw after the pilot hole was drilled, and that is now in place and running fairly smoothly. Now the one downside to these wiper ones is that it does apply a little bit of friction to the wheel so that it doesn't always run quite as smoothly. You can improve that by just bending in the wipers very slightly, but I tend not to do that unless I really need to, because every time you bend the little bit of phosphor bronze there, it does weaken it slightly. But anyway, that's in place. As I say, you can apply a little bit of super glue if you wanted, just to hold it in place, but this one is nice and solid. One thing to bear in mind is that these screws sometimes do protrude, like it does on this one. In this particular instance, because of the clearance between the bogie and the underside of the coach chassis, nothing rubs, so it's absolutely fine. I'll apply a little bit of black paint or pen to that just to dull it down, but sometimes you may need to just trim or file that flush just to make sure it doesn't cut. But anyway, we're fine in this instance. So what I'm going to do now anyway is to get the wires that we need, and I'm going to solder those onto the little tabs that are provided, and then we will feed them up through there and back into the inside of the coach. So in terms of the type of wire I'm using, this is just offcuts actually from some old decoders and so on. You don't want it to be too thick. If it's too thick, it may start interfering with the movement of the bogie. It becomes harder to route and all the rest. But equally, because there's going to be a wee bit of movement here, you want a gauge which is reasonably big, so that it's not going to snap at the slightest sort of tweak or whatever. But so I think old decoder wire is a pretty good compromise in terms of strength and size. So anyway, let's just clean the tip there. Tiny wee bit of fresh solder there. And let's get in and get it soldered on. Okay, so that's one done, and I'll do exactly the same on the other one. Okay, so that's the two wires soldered on. I've just poked them up through the hole in the bogie and they've come up through the top. What I like to do sometimes, and I've done it on this one, is just give a wee twist, just a few twists, as if you're kind of creating a wee bit of a ponytail, just for the first maybe sort of half a centimetre. I think it can just give a little bit of extra strength to the two wires and also stop some snagging individually. But anyway, so that's the bogie prepared. I've done a quick continuity check, so I know that there's power it will get from the wheels or the rails to the wires. So that's brilliant. We'll set this to one side anyway now, and then we're going to bring in this switch here and install the switch into the chassis as the next step. Okay, so I found two suitable bits of wire. They don't need to be colour coded. It doesn't even matter which way round it is, because it's just a switch on one leg. But anyway, let's one leg of the circuit. But let's apply a little bit of flux there, and a little bit of flux just the ends here, just to help everything flow nicely. And we're just going to tin those legs, and we're going to tin the end of the wires as well. So let's just clean the soldering iron there. Got way too much solder out. Right, okay, so let's just tin these wires quickly. There's one, there's two, and we will just tin the ends of these here. That's one tinned. That's the second tin. There's a wee bit more on, I think. And just a tiny wee bit more on there too. Great. Okay, brilliant. So that's them tinned, and I'm just going to line them up and solder them all together. Okay, so we popped a little bit of insulation tape over the top of the switch contacts just to make sure that there's no potential at all for any shorting out. We brought these wires to the centre here so that they line up with the hole which is in the base of the internal section of the coach, and we're going to solder these wires onto the circuit board that we prepared earlier. So I think I'll start with the track feeds, and then we will then solder in the switch wires as and where necessary. So let's get this first track feed soldered on here. So as ever, I tend to find that blue tack is the easiest way to hold these tiny fine wires in exactly the place that you want them. So we've got that first wire. This is the non-switched track feed. So we've got that in place, and we'll just pop a wee daub of flux on there just to make sure that everything flows nicely, as I've probably said at least 5 or 6 times in this video already. We'll stick a little bit of solder just onto the tip here, and I'll freestyle it using my right hand despite being left-handed, and just solder that on there. Okay, that's looking better. Great, okay. Okay, so I'm just going to solder in one of the switch wires, and the reason I'm going to do that is that the red and whichever switch wire we choose, the purple in this instance, they're the simplest to get in because we don't need to do any jumpers or anything else. But anyway, we'll get this one soldered up now. So I'm just going to hold it there with the pliers. I popped some flux on already, so let's just heat this up here. Let's get this in there. Great, there we go, that'll do. Excellent. So what we now are left with is the track pickup that we want to have switched and the switch wire that we're going to do that with. So what we need to do now is to solder this onto one pad here and solder this onto the same pad, so the wire will come up here, sorry, the voltage current will come up this one, it will go down this one, through the switch, back round and then into the rectifier, and if switched on, make everything live. So I think what we'll probably do is just twist these together first of all, just to make it easier, and then we'll solder them down onto one of the two pads down here. Okay, so I've twisted these two wires together just to hold them in place, and I'm just going to tin one of the pads here. So either will do, just use this one here. Great, okay, so that's the pad tinned. Let's bring these in while everything's still got a bit of heat in it. Brilliant, okay, so that is the input side of it all soldered up. We've got one track feed coming in and going straight to the rectifier, second track feed coming into this tab, going down to the switch, back out the switch, and then into this side of the rectifier here. So that's this all set up and ready to go, and all we need to do now is to fit the tail lamp in here, hook it up, and hopefully job should be a good one. Okay, so I've just gone ahead and popped the interior back in now. Everything is routed up here, through here, and here we've got the little circuit board module. I have bent that capacitor round so that it will slide in there. One side will be in this compartment, one side in that compartment. So what we need to do now is to bring the lamp back into the frame, and we want to be installing it on this side at the back of the carriage here. So we'll be drilling a little hole in the right place, cutting this wire, feeding it through, and then soldering everything back together, and then connecting the flasher unit onto here. Okay, so looking at positioning the tail lamp on the back of the coach. First of all, I'm using one of the kind of 1980s era British Rail flashing lamps. Now, I know if this was a Mark I coach with early diesel, an oil rear lamp, whatever, steam, that kind of thing, it wouldn't be a flashing lamp, but well, this is the only one that I have in stock just now. But secondly, no, it has arrived at Strathpeffer Junction very much as a kind of heritage coach that has arrived and will be departing as such, so a flashing lamp works perfectly in that context. But anyway, you can do whatever you want. You can use a static red, you could use a flashing red if you want, whatever fits your era. But anyway, in terms of the lamp irons in the back here, there is one just here on this side here, and there's one on that side. We'll be putting it on this side here. On Mark II and 3 coaches, you tend to see them a bit higher up where the lamp iron is, but on this one the lamp iron is a little bit lower down, and the various photos I've been looking at prototypes have them a bit lower. So we'll be popping the lamp down here, and the way that we're going to do that is to get the pin vise with a suitable sized drill bit. I think this is probably about 0.7 of a mil, something like that, but whatever works, and we'll drill through carefully from this side, and then we'll be fitting that through in just a second. Okay, so that's the light separated from its connector here, and we've got the flasher unit too. So we'll leave the flash unit to one side just for the moment. What we're going to do now is just to feed these wires through the hole that we've created here. Right, it's a bit like threading something through the eye of a needle, this. There we go, great. Okie dokie. Let's use these tweezers just to pull these up. So that is the light fixed in there. Great. So what I'll do is get a little dab of super glue, just pop that on the back here, hold it in place, and once we've got that, then we're on the home leg, and we can get everything soldered up together, fit it to the circuit board, and test it. Okay, so I've just applied the super glue to the light there. As ever with these things, less is more, because we don't want to get that awful white sort of pattern spread all over it. So let's just feed these up slowly. Right, and there we go. And I'll just hold that in position there. Great. So what I'm going to do is just give this a really quick scoosh with some accelerator. So I should just bring it here. Great. And that will make sure that is held securely in place. And now onto the soldering. Okay, great. So I have the plug soldered back on. Popped a wee bit of heat shrink over this just to make sure that the short potential is limited. And the last thing that we need to do here is to connect the flasher unit and socket onto the little circuit board that we made. So the black wire here is the negative or ground, as we would expect, and the red is the positive. So the black wants to go on this side here and the red wants to go on this side there. So I'll probably do this off camera because it's going to be a wee bit fiddly, but anyway, I'm sure you know how to solder on wires by this stage in it. So we'll get black to the negative side and red to the positive side. Okay, so that is the soldering finally completed. I've got everything wired up as it should be. I have fitted the circuit board back into the slots that I've designed for, so the cap in one side and the circuit board in the other. What I'm just quickly going to do is to plug the flasher unit and the lamp in together, apply a little bit of DCC power just to make sure that everything's working and it's flashing. This is polarity dependent, so you need to get them the right way around. Worst case is you'll get them the wrong way around and they won't work, but it's best to do it now before you put the lid on, just in case you have put it the wrong way around. But anyway, I'll give it a quick test just now off camera and get it the right way around. I'll get the lid back on and then we'll take it off to the track to hopefully, fingers crossed, see it flashing for real. Okay, so I took it to the test track, applied some DCC power, and this is not going to be the last bit of soldering that I do on this project. What I found out is that the light, everything works fine technically. The problem is the light barely flashes. It's more of a constant red with a very slight flicker. And after a bit of head scratching, what I've worked out is that the flasher units that I bought from eBay do say that they work from about, I think it's 9 volts up to 16 volts DC, and that should work absolutely fine for a rectified DCC track feed. However, the problem seems to be the way that they have wired these up, and I'll not go into all the detail, but anyway, while it can handle 16 volts, it doesn't actually flash very well at 16 volts. So we need to reduce that voltage down. Now, quite often the way that you can do that is just to stick in a suitable resistor, and that will reduce things down, and that'll be fine. However, the way that these flashing units are constructed, to cut a very long story short, you can't actually do that because by adding additional resistors you reduce the current that is going to the flashing unit, and that actually prevents it from working properly, and again, you don't get the flashing how you want it. So the little addition that I'm going to have to make on this particular setup is to add a voltage regulator into the circuit. Now, you could add the voltage regulator into this original circuit just before the capacitor if you wanted, but that would then mean that you've got a 5 volts, because it's a 5 volt voltage regulator I'm going to use, you'd have a 5 volt feed, and that might be a bit low if you wanted to say to feed a load of cab lights. So what I'm going to do is just create a kind of add-on voltage regulator circuit, and the way that we do that is by using one of these little voltage regulator chips. They are what are they called? Yeah, they're 5 volt, 550 milliamp. TS2950CT50. I'll leave a link anyway in the description below. And we also need a capacitor just to smooth the output. Now we could use, I think, a 1 nanofarad, or sorry, 1 microfarad capacitor, which is a really small one, so it doesn't take up much room. Unfortunately, I don't have any in stock at the moment, so I'm going to use a 1000 microfarad capacitor, which is total overkill. I don't mean there's absolutely bags of stay alive capacity in this, but anyway, it'll work. But for anyone following this in the future, you can get away with a smaller capacitor. Anyway, so without any more blabbering, because this is now becoming a longer video than I had anticipated, I'll pop together very quickly the voltage regulator circuit. Okay, so it's a pretty simple circuit. It's the voltage regulator, which has an output leg, a ground leg, and an input leg, and just a capacitor. As I say, this is the 1000 microfarad, but I think you can use as low as a 1 microfarad. So it's just a very small electrolytic capacitor and a tiny wee bit of circuit board. Now, what I've measured up for this particular one, or particular project, is that it will fit in this little section here, which is a blanked section on the door, so we'll not be able to see it. It'll be completely hidden from sight, which is good because it's a fairly large capacitor I'm going to have to use. If you're using a tiny wee capacitor, you can probably squirrel it away on the floor and you'll never see anything. Okay, so I have knocked up a quick voltage regulator here. We've got the capacitor and the voltage regulator itself. I have got the input on this side, so that's the plus. We've got the output just on the other side, and then we've got the ground at this side. So that'll make it really straightforward to wire up. We'll just put it in series with the feed to the LED itself. To the flasher unit rather itself. On the back, just to give you a quick look, I have popped the voltage regulator in here. We've got ground, which has got the black covering on it there, just for ease of reference and to insulate. The black comes out here, and the two there. Anyway, it probably doesn't make a huge amount of sense just looking at this prototyping board like this, but I'll create a quick diagram and I'll include a link to that in the description below so you can see how to make it. What I would suggest is, if I was to start again, if I had realised this issue right at the beginning of the video, was I would have built this integrated into the circuit board for this particular light, flashing light. But anyway, these things happen when you're doing these projects. They don't always work out quite how you plan. So anyway, let's move on to getting this installed into the circuit that we've already put in the coach. Okay, so I've just jumped ahead and I've desoldered the flasher unit from the outputs of that original circuit board. And what we're going to do is wire in this to those outputs and then wire this onto that. So that's what we'll get on and do now. Okay, so that is the wiring all complete for the second time now. We've got the inputs coming from the bridge rectifier in this side, and we've got the positive output there, and then we've got the ground here. So what I'm going to do now that I have also connected the rear light, the tail light, into this circuit here, I'm going to squirrel this into the little section here, and then I'm going to pop this somewhere in there. I'll black tack it all down. I have given it a check and it does work fine. So once I've got it black tacked down, I'll put everything back together again, and then we'll put the lights off and we'll put this light on and show you the end result. Okay, so that's everything black tacked down, the capacitor and the voltage regulator in this wee nook and cranny here at the end there. So I'll just bring back in the sides of the coach and get the lid on, and then we'll head over to the test track. Okay, so the moment of truth. Let's apply some power. I'm just using some DC power at the moment, just to show that it does work on DC, but we'll put it on the DCC track in due course as well, just to show that. Anyway, let's pop on some power here and see how we get on. And there we have it. Fabulous. A flashing light. Simple, effective I think as well. But not too tricky a project. If I had not had the issue with the voltage regulator, it would have been dead simple. But hey ho, these things happen, and the voltage regulator can easily be incorporated into the original circuit if you need to, or as I've done here, you can add it as a wee added extra bonus as well. Okay, so that's us back at the workbench, and it's been quite an interesting project, certainly from my point of view anyway. Hopefully you guys have found the video interesting as well. It didn't quite work out how I had initially thought it would, but the end result is certainly it's a convincing and working tail lamp, which is what I was after. So what I'm going to do is just update the schematics with the little changes that I made as I was going along, and I'll make those available via the website and the description below. But hopefully if you are thinking about putting on tail lamps and you're keen to do it yourself rather than using an off-the-shelf option, that this is perhaps a kind of method that you might be interested in using yourself. Anyway, right, I will stop blabbering away for this one. I hope you very much enjoyed it. If you have, give it a thumbs up. If you're not already a subscriber, please feel free to do that. And I have a number of videos, including some layout updates and a few other bits and pieces coming along soon, so please do stay tuned for that. But anyway, for the meantime, all that remains to be said is thanks very much for watching, and cheerio for now. Bye-bye.